Today we're going to be learning about how to graph a rational expression, a rational function, using a couple different techniques we've been working with. Before we get started, we're going to review how to graph these two linear equations. If you remember from way back when, we kind of said that if you have a line equation, y is equal to 4, it's almost like a horizontal line drawn at the point y is equal to 4. So I'm going to go up 1, 2, 3, 4, draw a point, and then draw that horizontal line through that point. And then kind of conversely here, x is equal to some value, so there's no slope, there's an undefined slope rather. That's kind of a vertical line through that point. X is equal to -1. So I'm going to go left 1 and draw a vertical line through that point. So remember guys, a rational expression is a ratio of two polynomials. We kind of talked about these as rational expressions or algebraic fractions. So a couple examples of each rational expression here. We could just have a simple one, 1 over x, which we're going to be working with a ton today. Or we could add or subtract from that x, or even have like a quadratic on the denominator. So we're going to start by graphing this parent function y is equal to 1 over x. And we're going to do this by evaluating 1 over x at 5 different values. So I've got a table, an xy table set up for us. And every time that we evaluate, 1 over x, we're going to input a value for x and get out a y value, and then we're going to graph that point. Okay, so let's start with the x value -2. So we're going to do -2, -1, 0, 1, and 2. We're going to get out 5 y values. So let's evaluate f of -2 first. F of -2 is 1 over -2, so it's just -1/2. So now on my graph, I'm going to go graph that. I'm going to graph -2, left 2, and then down 1/2, which is about right there. Next up, I'm going to evaluate f of -1. So f of -1 is 1 over -1, which is just -1. And then just like I did with f of -2, I'm going to graph that point. So I'm going to go left 1, down 1. There's my new point. Next up, I'm going to graph f of 0. And this one's kind of tricky because it's like 1 over 0, which we can't really divide anything into 0 pieces. So this is actually undefined. So we'll talk about that a little bit more in a moment, but the only thing you need to know for now is that at this point, 0 comma undefined, that nowhere where x is 0, so at any place where x is 0, nowhere exists. So we can't really have a point at the origin. So let's keep going. Let's try to see kind of the formation of this graph. So I'm going to graph f of 1, which is 1 over 1, or just 1. And then finally f of 2, which is 1 over 2, or just 1/2. Okay, so let's go graph these 2 points, 1 comma 1, and then 2 comma 1/2. Okay, and what we're going to notice as we take smaller and smaller values, or bigger and bigger values rather, for x, or more negative values for x, what we're going to notice is that the points on this curve, they get really close to this axis, this x-axis. Okay, and also if we took fractions in between 0 and 1, so if we took like 1/2 for example, these points get really close but don't actually touch this y-axis. Okay, and this curve is going to kind of look like this. So it's a curve that goes through all of these points. It gets really close but doesn't actually touch each one of these axes. And you can kind of see this happening for both the negative versions and the positive versions of this curve. So if we go back up to that previous slide, we can actually draw on some asymptotes. So I'm going to draw my asymptotes in a different color, and asymptotes are imaginary lines. So there's something that the curve doesn't touch. So we're going to draw them kind of as like dotted or slashed line, dashed lines. So I'm going to draw those over the x and y axis, okay? And this is for the graph of y is equal to 1 over x. So this brings us to this idea of an asymptote. So an asymptote is defined as a line, a vertical or horizontal line that a graph or a curve approaches, but it doesn't intersect or cross over. So you can kind of see on this horizontal asymptote, it's kind of like the one we just did, right? Where that all those points got like really close, but didn't actually cross over that x-axis. And same with that y-axis. All those points got really close, but didn't actually cross over or touch that y-axis, okay? We're not gonna talk about any oblique asymptotes, in this course, but definitely something to look forward to. So once again, your graph should never cross that asymptote. So the asymptote or the dashed line, it's kind of like a boundary line, like in sports, like in soccer. It's something you can't cross over. So it kind of helps us graph these curves, just because it gives us like a boundary, something to aim for as we're getting infinitely close to it. So, once again, as we graph these rational functions, for this one, we kind of already did it, so we know that the points are at, 1, 1, and 2, 1 half, and -1, -1, and -2, -1 half. And we kind of had asymptotes at this x-axis and asymptotes at this y-axis. So I'm going to draw those dashed lines that are imaginary, they're not actually real. And then our curves get really close to that, asymptote. They don't actually cross over, okay? So then the question for this one is, can you write a line equation to describe these two asymptotes? So I'm going to highlight this vertical one first. So can we write, a line equation? Remember, vertical lines can kind of be described as x is equal to the value that the x-coordinate goes through. So the x-coordinate goes through 0. So this vertical asymptote is x is equal to 0. So then if I want to do the same thing for this, horizontal asymptote, or the one that goes left and right, I could, right? I could say that y is equal to 0. So this would be my horizontal asymptote. And as you graph all of these rational functions, it's important not only that you graph, 4 or more points, but also that you're graphing these imaginary asymptotes. And you're also hopefully labeling these asymptotes as well. So the last one we're going to do today is kind of an exploration that's going to lead us into the topic for tomorrow. So we have a rational expression, y is equal to 1 over x plus 4. So I'm going to get my xy grid out. I'm going to graph label a bunch of points in the table, and I'm going to use the points -2, -1, 0, 1, and 2, just like I did before, but I'm going to evaluate them in this new function now. Okay, so I'm going to evaluate f of -2 in 1 over -2 plus 4. I think that's going to give me a 1 over 2. Okay, so -2 is just going to be a positive 1 half. Okay, next I'm going to do -1, so f of -1 is equal to 1 over -1 plus 4, which is equal to 1 over 3. Next up, 0, so I'm going to do f of 0 next. So I've got 1 over 0 plus 4, which is 1/4. So you can kind of see these fractions getting smaller and smaller as we're going from left to right. Next up, I've got f of 1 is equal to 1 over 1 plus 4, which is 1/5. Okay, and then hopefully we kind of see the pattern. F of 2 is going to be 1 over 2 plus 4, which is 1/6. Okay, so I'm going to go graph all of these points. I'm going to do this in blue. So I'm going to graph -2 comma 1 half, -2 comma 1 half. I've got -2 or -1 comma 1/3, 0 comma 1/4, and then 1 comma 1/5, and then 2 comma 1/6. You can kind of see these points getting smaller and smaller, getting really close to that x-axis. The issue is these 5 points that we graph, they don't really give us the whole piece of the puzzle. They don't give us enough information to graph this whole thing. So I'm going to evaluate at a couple different points. I'm going to evaluate at, f of -4. I'm also going to evaluate at f of -5. And I'm also going to evaluate at f of -6. And hopefully this gives me enough information to graph the rest of this. So f of -4 is equal to, 1 over -4 plus 4, which is 1 over 0, which is undefined. Okay, so I found my asymptote. It's at f of -4. So I'm going to go to -4, and maybe in a different color even. I'm going to graph my vertical asymptote. So that's super important that you know where that vertical asymptote is. Another way to think about it is, hey, what number on the denominator is going to make this denominator 0? In this case, it was -4. So my asymptote was x is equal to -4. Next up, let's evaluate f of -5. So I'm going to have 1 over -5 plus 4, which is 1 over -1, which is just -1. So I'm going to graph -5 comma -1. Okay. And then finally, I'm going to graph f of -6. So I've got 1 over -6 plus 4, which is 1 over -2, which is -1/2. Okay, so I'm going to also graph that point, -6 comma -1/2. Okay, and we can kind of see, these curves form. We can kind of see this curve on the positive side of things get really close to that asymptote, and then kind of same on the kind of lower left half of this graph. I can kind of see those points getting really close to these asymptotes. The last thing I need to do, I need to draw my horizontal asymptote, which I did not do, which kind of goes through that y-axis, so that didn't change at all. So you can kind of see, y is equal to x plus 4, or y is equal to 1 over x plus 4, versus y is equal to 1 over x. You can kind of see that the vertical asymptote, it almost got like shifted by adding 4 on the denominator, shifted over 4 units. We'll talk about that more tomorrow.